All right, everybody, least common multiple. Now we're using three numbers, so let's remember a couple of things. A multiple is a number that we're kind of counting by, so if we had multiples of 6, that would be 6, 12, 18, 24, and so on. Least common multiple, we want the smallest number that all three of these will go into. So just some notes for you. When trying to find the least common multiple of three numbers, the method 2 way that I taught you with the upside down bridge doesn't work with 3. Okay, it'll give you a common multiple. It will not always give you the least. So make sure you have that down. When using the factor tree, any two can be in common. So you don't need something in common for all three numbers. We're going to show you an example of that here in just a second. So any two prime numbers can be in common. Remember, you can stop this video at any point to write your stuff down. So I have already factored these numbers out. 2 is prime. So it's only factors 2. I mean, I guess we could say 2 times 1. 1 doesn't really do anything for us. Factors of 4, 2 times 2. Remember, these are prime factors, everybody. Prime. And the factors of 15 are 3 times 5. So we've listed all the factors. Notice I got a little chart here. It just makes everything easier. We don't get things mixed up and lost and so on. So back up to this. Any two prime numbers can be in common. So let's look for two prime numbers. So I hope it's pretty easy to tell that we have a pair of 2's. So again, notice it doesn't have to be all three. Okay, we have a pair in common. Okay, so we have a pair of 2's. We have nothing else. So I'm going to count this pair of 2's once as itself. That's this first 2. So the difference between least common multiple and greatest common factor is we are now going to use everything that's left over. We're going to count that one time. So look what we've done. We took what they have in common, one pair of 2's. That's represented here. Then we included another 2 because that's left over. We included a 3 and a 5. Okay, multiply those out. 2 times 2 is 4. 5 times 3 is 15. 4 15s give you 60. Least common multiple is 60. Just a side note here. Another way, if you see this in your brain, some of you can make this make sense. You can take the largest number and count by multiples of that largest number and ask yourself, do the others go into it? For example, 15, do 2 and 4 go into it? No, they don't. So go up by a 15. You can go 30. Do 2 and 4 go? Well, 2 goes in, 4 doesn't. 45, neither of these guys go into it. Notice what we're doing. 15, up by another 15, up by another 15. The next 15 up is 60. 2 goes in at 30 times. 4 goes in at 15, actually. That's what we had. Least common multiple with three numbers. Okay, so let's try one. So at this stage, I want you to pause the tape and factor those three numbers. Factor tree those three numbers. All right, here's my prime factors. So if you have a mistake there, stop the tape and check it. Fix it. So I'm going to write these out. Here's my 3's for 9, 2 times 2 times 3 for 12, and 2 times 3 times 3 for 18. So let's review how we're going to find what's in common. So I see all of them have a 3 in common. So if you find something where they have one number in common throughout all of them, we're going to count that once. So this counts as 1, 3. I then see a pair of 3's, and I see a pair of 2's. So I've got a pair of 2's, a pair of 3's, and even though there's 3 of these here, we're still going to count this once. So we're counting 1, 2, 1, 3, and 1, 3. And look, we have a leftover here. So we have that 2 is left over. We're going to count that once as well. So look at what we have. We have a 2 from here. We have this 3 here. We have 3's in common here and a leftover 2 there. Multiply them together. 36 is your least common multiple. So then, I mean, just check it out. If we have, does 18 go into 36? Yep, twice. Does 12 go 3 times? Yes. 9 goes into 36 4 times. That is the smallest number, 36, that all 3 of these go into. Okay, try one on your own. So stop the tape, try it on your own. Okay, what you should have done is factor the 3 into their prime factors, write out their numbers like so. What do they have in common? A pair of 3's, we count that once. I see a pair of 7's. and I see a pair of 5s, don't you dare laugh at my squigglies. I also see, ladies and gentlemen, a 2 left over. So again, what do we have? We have 1 3 representing this pair here. We have a 7, this guy. We have a 5 for this, and a 2 is the last thing we have. Multiply those together. 7 times 3 is 21, 5 times 2 is 10, 21 and 10 is 210. Smallest number that all 3 of those go into is 210, a little more significant. Okay, moving along. I'm actually going to skip this. We're going to do this in class. So here is, you have this. This is a word problem, so feel free to read that to yourself. It has some weirdness that you're used to. If you stop it, stop the tape and read it. Okay, this is a least common multiple problem. So you've read it, you understand what it looks for. We're saying this leaves, the motorcycles leave every 16 minutes, the trains leave every 24 minutes. So what we're saying is, when will they leave at the same time? We want to find when is the next time that those numbers will be the same, the least common multiple. So at this point, I'm going to do the upside down bridge, the ladder method. Seems to be the easiest way. So 4 goes into 16 4 times, and then 24 6 times. I'm using 4. There's a greater number. You could have used 2. That works also. 4 and 6, 2 goes into those. Don't pick on my lines. 2 goes into 4 twice. 2 goes into 6 3 times. 2 and 3, relatively prime. Relatively prime. So I'm done. So I can take the numbers out in the front, 4 times 2, and I take whatever's left over. So this is a 6, this is an 8, 6 times 8. Least common multiple is 48. So it's a word problem. It looks the same. It is exactly what we did before, and now we're only dealing with 2 numbers. Pause it if you need to catch up. And here's your last one. Pause it and try it yourself. And this is almost exactly the same problem. So I'll let you take that, and that's it.